Hi everyone, welcome to this tutorial on 2D transformation in computer graphic and image processing laboratory. Today we'll be diving into program number 4 that showcases how to apply different geometric transformation to basic object, in this case a square. This tutorial is a part of a computer graphic and image processing laboratory and course code is 21CSL66. Next, we know the importance of 2D transformation. Before we get let's quick before we get started, let's quickly discuss the why 2D transformation are essential in computer graphic and image processing laboratory. These transformation allow us to manipulate object in 2D space, which crucial various applications such as computer-aided design means the CAD, video game development, image editing, and computer vision. After all the code, let's know the real world application. When or where to use this real world application. 2D transformation have numerous real world application, including computer aided design means a CAD software for creating and manipulating 2D design, video game development for positioning and animating game development, image editing software for resizing, rotating, and moving image elements. Next is computer vision for object tracking and image registration. Before typing the program code, just refer the I updated the computer graphic and image processing laboratory in our website. So go to any browser and in the search bar type the our website name called search creators 21CSL66, then press enter. Here list of links, it will show the first link. Click on this link, then it will open. Scroll down to below. Here pop out this and download or refer program number 4. Understand purpose, and if you wanted to copy the code, just click on the scroll down to below and click on the 2D transformation basic object, this link. It will go to the program code and copy it and paste the in your VS Code interface. Previous videos I am created the CG laboratory folder in the VS Code, and I created also program 1, program 2, and also program 3. Same as the program 4, I created the file name as program 4 in the VS Code. Program 4 04.py extension, and here this file will contains all the program. Okay, so I typed now. Okay, so let's through this code in advanced way. Firstly, importing libraries. The first library is CV2, is the OpenCV for open source computer vision library, which provides a vast collection of computer vision algorithm and utilities. Next library is numpy, is a powerful numerical computing library that provides support for large multi-dimensional array and matrices, along with the large collection of high level mathematical function to operate on these arrays. Next is defining canvas dimension. The dimension of the canvas are set to 500 pixel and 500 pixel also. This canvas will serve as a workspace for our geometric transformations. And the next is creating blank canvas. A 3D numpy array is created with specified dimension 500 cross 500 and 3D 3 color channels RGB, red, gray, and blue. Next is the data is set to np.uinit8. It means unsigned 8-bit integer to represent pixel values ranging from 0 to 255. All pixel values are initialized to 255 representing a white canvas. The next, defining initial object. The initial object is a square defined by an array of 4 points. The object points, that is object point. And next, these point represented the x and y coordinates of the square vertices in a 2D Cartesian coordinate system. The data is set to np.init 32 int bit signed integer to ensure accurate representation of the coordinates. And next, defining transformation matrices. The translation matrix. These 2 cross 3, 2 by 3 or 2 cross 3 or 2 by 3 matrix is used for translating or moving the object in 2D plane. The third column represents a translation vector 100, 50. Next, a rotation matrix. This matrix is obtained using CV2 dot get rotation matrix 2D, which calculates the rotation matrix for a given angle 45 degrees and a pivot point 150, 150. The scale factor is set to 1. And the next, scaling matrix. This 2 by 3 or 2 cross 3 matrix is used for scaling or resizing the object. The diagonal elements 1.5, 1.5 represent the scaling factors in the x and y directions respectively. And next, applying the transformations. The transformation are applied using matrix multiplication between the transformation matrices and homogeneous coordinates, means augmented with a third coordinate of 1 of the initial object's point. The np dot function is used to perform the matrix multiplication, and the result transferred points are stored in new arrays called translated object, rotated object, and scaled object. Next, drawing object. On this canvas, cv2.polyline is a function from OpenCV that draw polygonal curve, in this case square, on the canvas. And next, each set of points, means the initial, translated, rotated, and scaled, is drawn with a different color for visualization purposes. The next is the true parameter. cv2.polylines indicates that curve should be closed, means forming a closed polygonal. The next, line thickness is set to 2 pixels. And the next, displaying the canvas. cv.imshow is used to display the canvas with drawn object in the window titled 2D transformations, waiting for a key press. Next is waiting for a key press. cv2.wait key of 0 is a function that waits indefinitely. 0 means forever. For a key press, this line is necessary to prevent the window from closing immediately after displaying the canvas. And the last but not least, closing window. cv.destroy all windows function is function that closes all the OpenCV window that were open. This code demonstrated on the application of various 2D geometric transformation, means a translation, rotation, and scaling using matrix multiplication and homogeneous coordinates. And it also showcases the power of numpy and for numerical operation, and OpenCV for computer vision tasks such as image processing and visualization. These techniques are widely used in computer vision applications like object tracking, image registration, augmented reality, and computer graphics. Understanding the underlying mathematics and algorithm is crucial for advanced computer vision and also image processing tasks. After understanding the line by line each of code, then run this program through in the navigation bar in here. Run the program. Here click on the run function, then start debugging and select the Python debugger and select the Python file. It will open the output like this, and this is the our output of the we are typed program in a square shape. Okay. registration. And next, in conclusion, in this tutorial we learned how to apply various 2D transformations such as translation, rotation and scaling to basic object using Python and OpenCV in program number 4 of the computer graphic and image processing laboratory course, and the course code is 21CSL66. I hope you found this video helpful and informative. Feel to free experiment with the code, modify it, explore further application of 2D transformation. Happy coding and thank you for watching.